If you put a colorful image into Photoshop or Instagram and blur it, you'll see a weird dark boundary between adjacent bright colors. Gross. In the real world, out-of-focus colors blend smoothly, going from red to yellow to green, not red to brown to green. This color blending problem isn't limited to digital photo blurring either. Pretty much any time a computer blurs an image or tries to use transparent edges, you'll see the same hideous sludge. There's a very simple explanation for this ugliness, and a simple way to fix it. It all starts with how we perceive brightness. Human vision, like our hearing, works on a relative and roughly logarithmic scale. This means that flipping from 1 light to 2 changes the perceived brightness a ton more than going from 101 to 102, despite adding the same physical amount of light. Our eyes and brains are simply better at detecting small differences in the absolute brightness of dark scenes, and bad at detecting the same differences in bright scenes. Computers and digital image sensors, on the other hand, detect brightness purely based on the number of photons hitting a photodetector, so additional photons register the same increase in brightness regardless of the surrounding scene. When a digital image is stored, the computer just records a brightness value for each color, red, green, and blue, at each point of the image. Typically, 0 represents 0 brightness, and 1 represents 100% brightness. So 0.5 is half as bright as 1, right? Nope. This color might look like it's halfway between black and white, but that's because of our logarithmic vision. In terms of absolute physical brightness, it's only 1/5 as many photons as white. Even more crazy, an image brightness value of a quarter has just 1/20th the photons of white. Digital imaging does have a good reason for being designed in this darker than the numbers suggest way. Remember, human vision is better at detecting small differences in the brightness of dark scenes, which software engineers took advantage of as a way of saving disk space in the early days of digital imaging. The trick is simple. When a digital camera captures an image, instead of storing the brightness values it gives, store their square roots. This samples the gradations of dark colors with more data points and bright colors with fewer data points, roughly imitating the characteristics of human vision. When you need to display the image on a monitor, just square the brightness back to present the colors properly. This is all well and good, until you decide to modify the image file. Blurring, for example, is achieved by replacing each pixel with an average of the colors of nearby pixels. Simple enough. But depending on whether you take the average before or after the square rooting, you'll get different results. And unfortunately, the vast majority of computer software does this incorrectly. Like, if you want to blur a red and green boundary, you'd expect the middle to be half red and half green. And most computers attempt that by lazily averaging the brightness values of the image file, forgetting that the actual brightness values were square rooted by the camera for better data storage. So the average ends up being too dark, precisely because an average of 2 square roots is less than the square root of an average. To correctly blend the red and green and avoid the ugly dark sludge, the computer should have first squared each of the brightnesses to undo the camera's square rooting, then averaged them, and then square rooted it back. Look how much nicer it is. There's actually yellow there. Unfortunately, the vast majority of software, ranging from iOS to Instagram to the standard settings in Adobe Photoshop, takes the lazy, ugly, and wrong approach to image brightness. And while there are advanced settings in Photoshop and other professional graphics software that let you use the mathematically and physically correct blending, shouldn't beauty just be the default? This Minute Physics video is brought to you in part by Audible.com, the leading provider of audiobooks across all types of literature, including fiction, nonfiction, and periodicals. If you go to audible.com/minutephysics, you can try Audible out by downloading a free audiobook of your choice. I highly recommend The Humans, a novel by Matt Haig, which is a hilarious and fun story of an alien who comes to Earth on a mission of intergalactic importance and ends up noticing all sorts of quirks in human society and technology and mathematics. You can download this audiobook or a free audiobook of your choice at audible.com/minutephysics, and I'd like to thank Audible for helping me continue to make these videos.